Welcome to another Forge College Explainer. So, in our previous lesson, choosing the right network for your deployment, we focused pretty heavily on the theory, right? Well, today, we're literally throwing theory out the window. We're treating Solana's Devnet as our ultimate engineering flight simulator. It's time to get our hands dirty, run an actual test deployment, and see exactly what kind of real-world turbulence we run into.
Let's do a quick flyover of today's schematic. We've got 6 stages. 1. Welcoming you to the sandbox. 2. Prepping your engineering tools. 3. Executing the test flight itself. 4. Following the meta-fees. 5. Documenting real-world risks. And 6. Putting together your production readiness artifact.
All right, stage 1. Welcome to the sandbox. Let's talk about the Devnet testing phase.
You know, reading about a bicycle is very, very different from actually getting on one and riding it. Imagine the absolute anxiety of an untested mainnet deployment. You're walking into a storm where a single bug costs you actual, real-world money. Contrast that with Devnet. Devnet is our low-cost laboratory sandbox. It's the exact same architecture, but it comes with a safety net, so we can break things, test things, and iterate without draining our bank accounts. But that brings up a good question. How do we get the fuel for this test flight without using real cash? Well, enter the airdrop. It's basically like asking the network for monopoly money. It gives us fake SOLs so we can execute our real transaction logic safely before a real credit card is ever involved.
Moving right along to stage 2, prepping your engineering tools. Let's set up the workbench. Before takeoff, we've got to inspect our gear. You're going to need 4 main tools on your workbench. First up, the Solana CLI to configure your network. Then a key pair to securely sign your transactions. Third, the airdrop commands to actually fund that wallet. And lastly, Node.js, combined with Web3.js, to write the scripts that'll send our transactions automatically.
Okay, stage 3, executing the test flight. Time for our very first end-to-end Devnet transaction. Let's go ahead and fire up the simulator. If you're doing this on the command line, it's 3 quick steps. You point your URL to Devnet, you generate your key pair identity, and you request an airdrop. Now, a quick heads up here, Devnet airdrops are heavily rate limited. You basically just have to hope that airdrop bouncer at the network door likes your vibe today. If he blocks you, don't panic, just wait 30 seconds and ask again. Now, if we look at the programmatic Node.js path, the logic is just brilliantly automated. We connect to the RPC, we construct our transfer instruction, let's say we're sending 0.001 sol, and then we hit send. We wait for the network signature, and finally, we fetch the metadata. That signature, that is our receipt. It's absolute cryptographic proof that our flight landed safely.
Which perfectly transitions us to stage 4, following the meta-fees. We really need to understand our costs.
So now that we have our receipt, let's pry open the black box and see what this flight actually cost us. You're going to encounter a massive number here, so let's establish a golden rule right now. 1 billion. In Solana, you pay your fees in lamports. Think of it like this. If sol is the dollar, lamports are the cents. But there are 1 billion lamports in a single sol.
Visualizing this conversion is absolutely vital for your math. Your script's metadata is going to hand you a raw integer, something like 5,000 lamports. To find your actual real-world cost, you just divide by 1 billion. That's 0.000005 SOL. Tracking these micro-costs in the safety of the sandbox is quite literally the only way to accurately project your budget for mainnet. Stage 5. Documenting real-world risks, dealing with turbulence. Look, no simulator session is ever perfectly smooth, and honestly, we want to experience that turbulence now. Notice the 3 real-world risks we've captured here. You've got airdrop rate-limiting delays, you've got non-representative fees, because fees on Devnet might look cheap now, but they can completely spike under mainnet load. And then there's transient or PC instability. That's basically when the nodes you're talking to just decide to take a spontaneous coffee break. Documenting these little hiccups is absolutely critical. And finally, stage 6, your production readiness artifact. Let's build your blueprint. It's time to gather all our findings into a tangible blueprint. We call this the transaction_demo artifact. It's a simple 3-part checklist you need to pass this stage. Your confirmed transaction signature, the JSON snippet of your fee data, and a short 3 to 5 sentence risk log. Did a node timeout on you? Write it down. This right here is a core philosophy we explore in our other learning programs at Forge College. We don't just write down problems to complain about them, right? We document this isolated behavior so we can engineer real, actionable mitigation strategies for production. This exact mindset shift is how professional Web3 developers operate.
So I'll leave you with the ultimate question. Is your code genuinely ready for the mainnet storm? Or are you just sort of hoping for the best? Devnet gives you the sandbox, sure, but only meticulous documentation gives you the confidence to actually launch. Build your artifact, test your limits, and when you're ready to master the rest of the Web3 ecosystem, come visit us at forge.college. Thanks so much for exploring with me in this explainer, and I'll see you in the next one.